Oh, I saw your question in the email. It says use Pythagorean theorem to find the length of the missing side of the right triangle. So let's do that first. So we've got this right triangle. One leg is 12, the other leg here is 16, and this is the hypotenuse, always opposite the right angle, and they usually call it C. So here's Pythagorean theorem: a squared plus b squared equals c squared. So you plug in the two known values, 12 and 16, and you can find the hypotenuse, c squared. And so we square 12 and 16, and we add, we get 400 equals c squared. We're looking just for the positive square root, c be square root of that, 400, which is 20. So that's the first thing you want to do, is use Pythagorean theorem to find the length of the missing side, which is the hypotenuse here. Then they want you to find the values of each of the 6 trigonometric functions. So you need to look up the definition. It's in the book and in the videos and stuff. The definition of the 6 trigonometric functions in this section 1.2. If you look up the sine of an angle, it's going to say it's opposite over hypotenuse. If you look up the cosine of an angle, it's adjacent over hypotenuse. Okay, and you can look up the tangent, etc. So I'm just going to look at a couple of them here. So sine of theta is opposite over hypotenuse. So where's theta at? Well, theta is right here. So the side opposite would be A. The hypotenuse is always, C. And in this case, adjacent, is B. So sine of theta is opposite over hypotenuse. So sine of theta would be 12 over 20. And you always have to simplify. That's simplified, 3/5. Cosine of theta is adjacent over hypotenuse. So theta here, adjacent 16 over 20. And you'd have to simplify that. Now, I don't know if you've had time to read the textbook, but the textbook really, it's well worth reading this section 1.2. It provides a really nice introduction to this material. So I encourage you to take a look at the book. Hope this helps.